Hello, this is Rahul. In this lecture, I am going to explain which is introductory to IPv6 IP address. So earlier we used IPv4 version 4. It has 32-bit size and which will use to identify the connection in the internet of your device, right? So now it has converted to the next generation IPv6. It has size 128 bits. Let's divide in some groups. Let's divide the group of 8 bits. Sorry, 8, not 16 bits, right? 16 bits of groups. Then how many groups are possible? We may have almost 8 groups, right? 128 by 16, we will have 8 group, right? So that's why we have I have written 8 groups. You can see over here, right? One more things, these are the hexadecimal digits. You can see here 2 is hexadecimal, 0 is also, because F is also present here, E is also there, you can see. So these numbers are hexadecimal, so each digits we can represent in 4 bits of binary. So that's why if we multiply 4 times, we get 16 numbers, so 16 bits. So that's why these are the groups, right? So we write first group and then followed by columns. In IPv4, we were simply putting, instead of the column, dot. So here we use column, right? Then followed by next group, followed by column, then next group followed by column, next group followed by columns. In this way, so on, you write the IPv6 addresses, right? So I have written same things. So if you have this hexadecimal numbers, you can convert into binaries, like so 2 numbers. If you convert in binary in hexadecimal 0010, you will get you convert these numbers, you get 00, so on, right? So abbreviation rule, we will look at that. So sometimes in exams this type rule is, this rules is asked, right? So what are the rules? We have 2 rules only. First one is we remove the leading zeros. Suppose if you have number 0 to, can you write these two? Are these two these two numbers same? Yes, these two numbers are same. We can write in only 2, right? Suppose if you have number 003, you can write as 3. So leading 0 you will remove and write it as 3. Similarly, if you have number 001, you can write it 1. 00F, you can write it 020, you can write it like this, right? So you have to remove leading 0. You please make sure you do not remove this 0 handle. You cannot write like this, or only 2 you cannot write, because this 2 is not equivalent to 20. You have to remove all the zeros which is leading to these numbers, right? So second abbreviation rule is use double colons. Why do you use double colon? These symbols. Okay, so suppose you have given IP address, this one, right? In this IP addresses, what you see, there are lots of zeros. Why lots of zeros? Because the size of IPv6 is very big one. Then you get lots of zeros in IPv6 addresses. So that is the reasons there must be some rule to omit the sequence of zeros. So how do we omit, or how do we remove the zeros to represent in short way, right? So suppose you have given IPv6 address, what we see, you find out in any sequence of zeros of group. Suppose this group represents this 0 number, this group represents 0 number, this group 0. We have 3 ones, right? We can replace all these 3 groups by this column, double column. We write over here, we can write this number as it is, this number as it is. Instead of this, we write only double columns, then followed by this number, right? In this way we can write. Make sure that you can use only 1 double columns. You cannot use 2 double columns. This is invalid address, because If you have used these two double colon abbreviation, what it means, you are not able to identify how many zeros in between these two groups, and how many zeros in between these two numbers. So that is the reason, so we only one double column is allowed, right? So if we want, suppose what are type of addresses we have. First one is unicast. Unicast is basically if you want to communicate between these two devices individually, as we use if we want to send a message from Instagram to other persons, that is unicast addressing, right? So multicast is if me as a person want to send some any message to group of persons. Suppose this is a group, so I am this A persons, I am sending the message to this group, then this kind of addressing if you use that is multicasting, right? Anycast is a very important one with this IPv6. If this A device, suppose these are the DNS servers, right? These all are having the same job and they are doing the same duties, but if A want to communicate one of these two, suppose A can communicate with B effectively, then what we'll do is A will do Anycast with these C or D and this group, but A will only communicate with the optimal path. If any router which is closest to this one A, then the A will communicate with that router only, right? This is Anycast one, right? So as we know, our devices are our devices they uses the IPv6 IPv4. Can we migrate to IPv6 in a single day? I don't think so it is possible. Lots of devices we have made like routers and switches, all those devices, most of the devices they are being using the IPv6 IPv4, and can in single day changing or to change all devices is not possible at all. So do we have some solutions to migrate IPv6? So that's why we can use the services provided by IPv6 effectively and efficiently. So there are some strategies we do follow to use the IPv6, right? So first one is strategy is dual stack, and the second one is tunneling, and third one is header translations. We will say first dual stacks. Dual stacks is we will have two choices, whether we will use IPv6 and IPv4. As we see in our mobile phone, we get two type of IPv6 and IPv4. Suppose if me as a devices, I am requesting to DNS servers, and the DNS servers if giving response of packet IPv6, right, then I will communicate with the servers with IPv6, not IPv4, right? If DNS server is response with IPv4 packet, then I will use IPv4 packet. This is very simple ones. The dual stack means I have two choices. Either I will use IPv4 or IPv6. But if I have choice of using IPv6, then I will definitely go for first IPv6, right? The second strategy is tunneling. Tunneling is what? Suppose this suppose it's first we say the notations, right? Notations. We have a packet. You can see it has two parts. First one is a data part and header, IPv4 header, right? So if this is a IPv6 header, we will put this one in data part, encapsulating data part. Why? Because if any networks, any routers which is which is the passing this router, this packet will not touch this data part, and the routers will look at the header. So this header is actually IPv4 headers. Suppose this is the network and this is using the IPv4 address, right? Out of this network, some devices are there, they are using IPv6 address. Both these two devices are using IPv6 addresses. Our top priority is to migrate from IPv4 to IPv6, right? How do we do it? Suppose we did we have encapsulated IPv6 header to data part, right? At time t0, this device has generated this packet, and this packet has been transferred to the network, and networks will understand that this part is only data part, and we'll look at IPv4 header. So that's why all the routers present in this networks, they will forward the packets to the next device and will move toward the destinations. And when this packet come out from this networks at the moment, so this IPv4 header will be removed, and then after removing, there will be only two headers. First one is IPv4 and data part would be there in IPv6 packet, right? In this way we can use the services of IPv6. The third one is header translations techniques. There we have only one options to translate IPv6 header to IPv4, because there are two persons they want to communicate, but one device use IPv4 and another device use IPv6. Then we don't have any choice. We simply need to translate our IPv6 header to IPv4. Thank you.